glial cells, not too well organized. They mostly be at regular intervals here, for reasons you'll learn about. And then it'll get to this point, and here's the first mystery. So we're going to get to this point. What's going to happen to the signal? So if this were a real electrical signal, it might get to be less and less and less as you go through divisions. Many cells will connect to 200 other cells. So how is it that they manage to not lose the signal? And then it'll get to the other end here, where you'll see how it connects to another neuron. So what we need now is the signal itself. The signal is called an action potential. And it looks like this. It's a voltage. It's a change in voltage, which is goes from minus 70 up to about plus 50 and then back down again. And if we have enough of an input to these dendrites, this cell will make a decision. It'll say, I'm going to scratch my ear, if it's that particular neuron. And at that point, this action potential will leave this neuron, and it'll head down the axon, and it'll travel at about, oops, I guess this thing's in my pocket, which is why it's going backwards. Okay. So now it's heading down the axon. Mostly they don't stop for that, but they get to this point, and then, are you ready for this? It makes a second exponential. Yeah, and two of them go down, and this one gets here when, oops, and so we have actually a signaling system that's electrical that turns into chemical, and these are neurotransmitters that have fallen on the floor. The neurotransmitters are, and you can see they are mostly one color, but there can be two kinds of neurotransmitters in here. They can have two kinds of effects. That's sort of rare, but it's also possible. So now you can keep in mind that this neuron that you've seen structurally in this dramatic enactment has a number of properties that are really puzzling. How is it that this cell decided to make a signal? How does it travel at a constant speed without losing any voltage all the way down here? How does it become 2 when we get to this point? And how does it then turn into a chemical signal at this end that then tells the next cell, here's a signal for you, right? So keep those in mind as we now talk about how this actually works. This is actually just a model. This is not how it really works. Okay, thanks very much, Howard, I can, for our